So today we are going to begin the first section in our circles unit. So we're going to look at 10.1 properties of tangents. Now this section has a lot of vocabulary at the beginning. So I'm going to kind of zoom in and start here. Oops. Oh gosh. All right, let me give you a few moments to possibly pause the video, and I'd like you to write down these definitions. I will kind of talk through them and then draw a picture toward the bottom or maybe over to the side to give you a lot of details on this. So a circle. A circle is the set of all points in a plane that are equidistant from a given point called the center. So that given point is in the middle, and it's the same distance to the edge of the circle. And that is how a circle is formed. I'm going to maybe draw over to the side here. Let's do this. Okay, so there's my circle. Radius, a segment whose endpoints are the center and any point on the circle. So you might pause. Okay, I just drew a radius, a segment whose endpoints are the center and any point on the circle. So you can have an infinite number of radii, an infinite number of radiuses. In fact, that's how a circle is formed. Okay, a chord, this is probably new. A segment whose endpoints are on a circle. Doesn't have to necessarily go through the center. It can, but it doesn't have to. A chord is a segment whose endpoints are on a circle. So I just drew a chord in pink. It just is a segment, usually just in the circle somewhere, but doesn't necessarily go through the center. Okay, the diameter, though, is a chord. It's a special chord, and it goes through the center. Okay, so I drew a diameter. So it is a segment, which makes it a chord. And when it goes through the center, it's got a special name called a diameter. All right, a secant. It is a line that intersects a circle in 2 points. I'm going to draw another circle here. I don't want to get too much on one circle. Okay, I'm just going to draw a line. It's going to go through the circle, but not necessarily through the center. So something like this. That is a secant. Going through the circle, so it's a line. That's what makes it different than a chord. A chord is just a segment and intersects at 2 points. And then finally, a tangent is a line in the plane of a circle that intersects the circle in exactly 1 point, and that's called the point of tangency. So let's find a new color. Let's do this, I don't know, let's do this light pink. Okay, so the point, a tangent line, it's going to go through, like, it's going to be on the outside. It's going to intersect the circle at 1 point. Okay, that's the point of tangency. So a tangent can never go through the circle because that means it would intersect the circle more than once. So that would be your secant. Tangent will intersect at just one spot on the circle, and so it will be on the outside of your circle. Okay, so radius and diameter are probably familiar, but chord, secant, and tangent are going to be your new vocabulary terms to get used to. Okay, let's identify on number 1. We are identifying the segments. So tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent of circle P. So notice how the name of the circle is the center point, and so when you write down a circle, you can put that circle symbol with a point in the middle. That's the center. Okay, pause the video and please run through A, B, C, and D. Work on the vocabulary and let's see what you get. Okay, RT is going through the center, so that is best described as a radius. Oh, no, not radius, diameter. Gosh. Let me fix that before I go on. It's going all the way through, so that's a diameter. Okay, ray WT. All right, so it's going from W through T. Now, even though it's listed as a ray, I see it's intersecting at one point, so this is a tangent. Okay, so it can be a ray, not necessarily a line, but it can, as long as it's on the outside going through one point. Okay, P over to T, there's my radius. And then RQ, now it has a line symbol, excuse me, so that's referring to the line. That's your secant, not chord. If it said segment RQ, that would be my chord. Okay, let's go on to example 2. Use the diagram to find the given lengths. Okay, I want a diameter of circle P first. All right, circle P. So I'm going to say a diameter goes through the center. Now, see those 4s? That's telling us that each grid is 4 units long. So 4 and 4, that would give me 8 units. Diameter of circle Q. So I've got 4 times 4, so 16. Radius of circle P. So I can just take my diameter and cut it in half. Same with circle Q, 8 units. Okay. So sometimes we're on a coordinate plane and we can use the grids to tell us our length. All right, let's talk about a common tangent. So I'm going to add a definition here. So common tangent. So a common tangent, it can be a line, array, or a segment. A line, array, or a segment that is tangent to two coplanar circles. A line, array, or segment that is tangent to, and then the number, spell out the number 2, two coplanar circles. So I want a line, array, or a segment that's tangent to 2 circles, and those 2 circles have to be in the same plane. All right, so when I look at letter A, I'm trying to draw a tangent that touches each circle only once. So I can draw one kind of along the top here. It has touched once on that circle, once on that circle. I can actually draw another one along the bottom, kind of the same idea, kind of like this. So touching once, touching once. I cannot go vertically through it, okay? Because if I went like this, it's touching both circles right here and here, and so that would be touching it more than once. So there are only 2 common tangents. So try B and C. See what you can come up with. How many lines can you draw that touches each circle only once? Okay, on letter B, we can actually draw 4 of them. So I can go one time like right here. I can go one time on the bottom. I can also go kind of diagonally, like touching about right here, here. And I can go the other way diagonally. So I can get 4 altogether. And then the last one, there's just one. I can go this way. I can touch it one time here, and that's as far as I can get, or that's as many lines as I can get there. Okay, so that example was just really about getting used to that new term, common tangents. All right, we do have a couple theorems in this section. So the first one says, in a plane, a line is tangent to a circle if and only if it is perpendicular to a radius of the circle at its endpoint on the circle. Okay, perpendicular is the key word. So what this is saying, the only way that this line M is tangent is if it's perpendicular to the radius. Okay, that's really what it's saying. If it's not perpendicular to the radius, then it's truly not a tangent, which means it doesn't intersect the circle at only one point. So we are going to think about how to create a perpendicular angle based on things we have learned. All right, so let's turn the page to the next example. On this example, we're simply verifying that this is a tangent. So if segment AB is a radius of circle A, show that segment BC is tangent to circle A. So I'm trying to show, how do I know that that's a right angle? So what I want you to pay attention to is, if this is a right angle, then that means what I outlined in blue is a right triangle. So let's check, is it a right triangle? So we're going to use that converse of the Pythagorean theorem. Is c squared equal to a squared plus b squared? So let's check C, A, and B. So is 10 squared equal to 8 squared plus 6 squared? So is 100 the same as 64 plus 36? And yes, that's 100. That's 100. Okay, so I'm going to say here, triangle ABC is a right triangle. And then I'm going to say, therefore, segment AB is perpendicular to segment BC. Okay, now I could have looked at the other triangle. I could have looked at ABD and checked, does 8 squared plus 15 squared equal 17 squared? All right, so you're drawing back to your idea of converse of Pythagorean theorem. Okay, one more idea here, and that will wrap up tangents. One more theorem. Tangent segments form a common external point. Tangent segments from a common external point are congruent. So if RS is tangent and TS is tangent, and they are both coming from a single common point, then these lengths have to be the same. So those segments are going to be congruent. All right. So if you have two different tangents coming off of one point, those lengths are the same to each other. Okay, one more example here. QR is tangent to circle C at R. Okay, so this segment is tangent. QS is tangent to circle C at S. So we are told they're tangent. Find the value of x. So based on my rule above, if they're tangent, their distances to the circle are the same. Their lengths are the same. So now that I recognize that, I can just write an equation and we can solve for x. Okay, but the underlying idea is that tangent. So take away 5, 130, 27. Divide by 3, so it looks like we get 9 here. Okay, so the goal of this section is to work on the tangent segments theorem here, to work on the idea that the tangent is perpendicular to the radius, and work on all this vocabulary at the top. All right?